Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer sample paper 6 questions from RK Bali Navigation. The book I am referring to is 4th revised edition. So there are different editions of this RK Bali Navigation book that have been published over the years. The questions that I have extracted, the book that I have extracted these questions from are from 4th edition book. Even if you have any other edition book of any other edition, the questions are the same in the 4th edition book as well as 5th as well as 6th. I have checked all those questions, so maximum questions are the same. So no need to worry. Practice is practice, and conceptual. The main purpose of these lectures are to revise your conceptual concepts, to enhance your conceptual understanding, increase your confidence, and teach you, show you, demonstrate to you how to solve different types of questions. So let's begin with question 41. Aircraft is approaching to land and is exactly on the ILS glide slope. So let's say this is your aircraft. This is the runway. Okay. And this is the 3-degree glide slope of that runway. Aircraft is established correctly on this glide slope. Airport elevation is 2600 feet. That means elevation is always measured from mean sea level. So elevation of this airport is 2600 feet. Aircraft published outer marking crossing altitude is 4200 feet. So that means there is an outer marker which is blue in color always. An aircraft is expected to cross this outer marker at an altitude of 4,200 feet. Its QNH temperature is 1013. So QNH is 1013. QNH is nothing but atmospheric pressure, that is aerodrome pressure reduced to mean sea level. Okay, reduced to mean sea level. Temperature is outside temperature is very hot. It is plus 40 degrees Celsius. Which answer best describes the expected indicated altitude whenever the aircraft crosses outer marker? So that means here the question is asked, what is the altitude? What altitude will the altimeter indicate whenever aircraft crosses over this outer marker? Now, whenever you come into land for an ILS approach, or whenever you are executing an ILS approach, the ATC controller will give you the current altimeter setting that you must put in your altimeter pressure setting window. It can be QNH, it can be QFE. Without that, you will not be carrying out this ILS approach. So definitely your pilot, the pilot of this aircraft must have put the current altimeter setting QNH 1013 in his altimeter setting window. So if this is his altimeter, so in the altimeter setting window, the Colesman window, there will be 1013. Now when you put the current altimeter setting in the altimeter setting window, all the altitudes indicated by the altimeter will be the correct altitudes. So if you put the correct adequate or correction accurate QNH pressure setting, you will get accurate indications. If we put wrong pressure settings, all the altitudes or vertical distances shown by the altimeter will be with respect to a wrong datum. I have explained this concept of altimetry very well in the Oxford Altimetry playlist that I have made. I have also solved all the back questions of altimetry chapter from Oxford Met book. So do watch those video lectures. So if the aircraft pilot has put correct altimeter setting window, excuse me, the vertical distance or the altitude indicated by the altimeter will also be correct. So whenever aircraft passes over this outer marker and the outer marker, so the altimeter will correctly indicate 4,200 feet. Not more than that, not less than that. So indicated altitude will be 4,200 feet. But if the question asks you to find out true altitude of this aircraft, true altitude will be different from indicated altitude because of varying atmospheric conditions. If you are flying in a cold air mass, I have explained this in the Altimetry playlist. Do watch that video lecture. If you fly in a cold air mass like this, in a cold air mass, the true altitude of your aircraft is less than your indicated altitude. So altimeter may be showing 5,000 feet, but actual altitude at which you are flying will be less than 5,000 feet, 4,000, 4,500, any value less than 5,000. When you fly in a hot air mass or in a warmer than ISA air mass, the true altitude of your aircraft is more than indicated altitude. So your altimeter, aircraft altimeter may be showing 5,000 feet, but in reality you will be flying at an altitude more than 5,000 feet. 5,500, 6,000, 6,500, anything more than 5,000 feet. So if you're not flying in ISA temperature conditions, if you're flying in a temperature condition which is warmer than ISA or colder than ISA, the difference between there will be a difference between indicated altitude and true altitude of your aircraft. So you have to be careful about that. It is more dangerous to be flying in colder than ISA conditions because in those conditions, your true altitude of your aircraft is less than indicated altitude. So the pilot is disillusioned, meaning he's flying under, if he is not aware of this, or if he is not aware of this facts, of this important facts of altimetry, he may be flying under an illusion or under a misconception that he is flying at, that he's correctly flying at the altitude indicated by the altimeter, whereas in reality, he will be flying at an altitude much below that indicated altitude. Okay, so that is a grave mistake. That is very unsafe. Okay, if you don't know the actual altitude you are flying at, and if you are flying in IMC conditions, and you are not the visibility is too bad, you are not able to see a long distance ahead of you, below you, then you may get very close to a mountain before it becomes too uh, and it becomes too late to react. So that will be very unsafe. So that's why we say whenever you fly from high temperature to warm temperatures to cold temperatures, always have a lookout. Okay, always watch below your aircraft whether you are flying any close to obstructions. So let's say you're in this case you're flying at 40 degrees Celsius. Okay, 40 degrees Celsius at so there is ambient temperature or outside air temperature here is 40 degrees Celsius at 2,600 feet. So at 2,600 feet, ISA temperature is expected to be 15 degrees Celsius minus 2 into 2.6. So approximately 15 minus 2.6, 2 into 2.6 is 5.2. So 15 minus 5.2 is 9.8 or approximately 10 degrees Celsius. So according to ISA, the temperature here must be 10, but it is 40 degrees Celsius. It is warmer by it is warmer than ISA by plus 30 degrees Celsius. Big difference. So whenever you are flying in warm conditions, warmer than ISA conditions, true altitude is definitely going to be more than indicated altitude. So here your indicated altitude is 4,200 feet, but the true altitude of your aircraft will be more than 4,200. Okay, so how to find that out? The true altitude correction is equal to 4 into ISA deviation into per thousand feet. Per thousand feet. So 4 into 30 plus 30,000 feet. So you are currently flying at 4,200 feet. So 4.2. So 4 into 30 into 4.2 is equal to 504 feet. So that means true altitude of your aircraft is indicated altitude plus this correction factor 4,200 plus 500 approximately. So you're actually flying at 4,700 feet. You are actually flying at 4,700 feet, but altimeter is indicating that you are flying at 4,200 feet. Okay. So next, question 42. Grid Mora value clear all terrain and man-made structure. So whenever you start flying your VFR cross-country flights, IFR cross-country flights, so let me see if I have this chart. You will be shown, you will be flying with the help of sectional charts in case of VFR. So a grid is nothing but a square defined by defined by two longitudes, two latitudes. Okay. So for example here, so you can see here it's 1706, right? So that means if you're flying in this particular region, you have to be at least minimum 1700 feet, correct? So everywhere it's indicated that 800, 800, 600 over here. So different grids, different minimum altitudes, 600 here, 700 here, right? So these are grid altitudes. So what is the purpose of that altitudes? What do they achieve? So the correct answer here will be grid minimum obstruction route altitudes, clear all terrain and man-made structures. So natural structures and artificial structures by at least 2000 feet, by 2000 feet. Remember this. Next, you are flying a heading of 300 with OBS to selected 300 as well. CDI needle shows 3 dots left indication and the 2 flags showing. If airplane is now turned to the reciprocal heading of 120, a new heading 120, what will happen to VOR indications? So here is your VOR. This is the north datum. You have selected your OBS 300. So that means there is radial 300 in question. Always draw the reciprocal radial as well. So the reciprocal of 300 will be 120. Yes. Okay. So your aircraft is flying heading 300, uh, and the CDI needle OBS. So let's draw OBS first. So OBS indication is set 300 with a 2 indication. That means you are on this side of the VOR and you are flying towards this VOR. Okay. So originally in ideal condition, you are expected to be on radial 120. You are expected to be on radial 120, flying inbound, heading 300. So you are flying that heading 300 correctly, but you are not on the radial 120. You are not flying inbound radial 120. You are deviated 3 dots right hand side. Okay, you are not established on radial 120. You are established. You are currently established on radial which is other than 120, maybe radial 110, any radial less than 120. How? Now the CDI is showing 3 dots left indication. That means it is showing 3 dots left indication. It is asking you to fly left hand side. It is asking you to fly left hand side. It is asking you to fly left hand side. If CDI is asking you to fly left hand side, that means you have deviated to the right hand side. Now going inbound, considering the OBS setting that you have put in this OBS selector, 300 with a 2 indication. With a 2 indication. That means going inbound towards the VOR, this becomes your left hand side, this becomes your right hand side. And if CDI is telling you to fly left, that means you have deviated to the right hand side. Right hand side means somewhere here, anywhere here. Okay. Now how many dots to the left? 3 dots left. 3 dots left means is equivalent to saying you have deviated 3 dots right. Now 3 dots means angular deviation of 1 dot is 2 degree in terms of VOR. 1 dot is 2 degree. 3 dots will be 3 to the 6 degrees. Okay. So that means aircraft has deviated 6 degrees to the right hand side. Okay. Going inbound 6 degrees to the right hand side. That means that this track will be 120 minus 6. Okay. With respect to the track, with the perspective of the track going outbound, okay, this becomes your going outbound, this becomes your left hand side, this becomes your right hand side. So this track is to the left hand side of this 120 track. So going left, you always subtract. So 120 minus 6 is radial 114. That means on instead of being correctly established on radial 120 inbound, unfortunately your aircraft is on radial 114, is on radial 114. Okay, 114, flying a heading of 300. So the heading that it is flying is correct, but because of winds or something else, it has drifted right onto radial 114. Okay, this is the case. Now the second part of the question states your aeroplane is now turned to a new heading of 120. So that means from a heading of 300, now you have turned your aircraft to a heading of 120. So that means the new heading of your aircraft is 120. So it will look something like this. 120 will be parallel to this radial 120. So heading 120. So what will be the changes in the OBS setting? What will be the changes in this OBS indicator? Will there be any changes? OBS indicator only shows the OBS setting that you have put. Accordingly, it will show to and from indication and the CDI indication. Is there any provision? Is there any space made for indication of heading in this instrument? No. Okay. And all VOR indications are with respect to your position. Okay, they do not consider the heading of your aircraft. Whatever the heading of your aircraft, the position that you are situated, the position that you are at, or the radial you are situated on, will be reflected or will be shown or displayed on your OBS instrument. So remember that. So even if you change your heading from 300 to 120, nothing significant or nothing at all for that matter will be reflected on this OBS indicator unless and until you change the OBS setting yourself. So the correct answer here will be CDI needle will shift 3 dots to the right, 2 flag will change to from, there will not be any changes in the VOR indication. Yes, because here it's explicitly written that heading is changed to a new heading of 120, and other than that, no other changes are made. No other selection is altered or changed. Okay, so that's why there will not be any changes in the VOR indication. Do watch all my VOR RMI lectures that I have uploaded from RK Bali, Oxford, Keith Williams. You will find them in the dedicated playlist I have made. One for RK Bali Radio Nav, another for Keith William Radio Nav, another for Oxford Radio Nav. So you'll find those lectures in that playlist. Question 44. In a Doppler VOR, the reference signal is the bearing and the direction of rotation of the bearing signal. So Doppler VOR is just like a conventional VOR. Okay. Now in a conventional VOR, we have two signals. A reference signal that is amplitude current reference signal that is frequency modulated, and a variable signal, a rotating signal which keeps on rotating 360 degree around the VOR beacon, and that is that is called variable signal, which is amplitude modulated. This is in case of conventional VOR. Now, in case of Doppler VOR, the operation remains the same. The principle of operation is the same. What changes is the modulation of the reference signal and variable signal. Now, in case of Doppler VOR, the reference signal is amplitude modulated and variable signal is frequency modulated. So it's the reverse of the conventional VOR. So this happened in case of Doppler VOR. So in Doppler VOR, the reference signal is amplitude modulated. So eliminate option Charlie. Amplitude modulated. Variable signal is frequency modulated, and the direction of rotation is anti-clockwise. So in case of conventional VOR, the direction of rotation is clockwise. This variable signal will rotate clockwise. In case of Doppler VOR, this rotating signal will rotate anti-clockwise, a 360-degree turn in anti-clockwise or counterclockwise direction. So option A. The radial will be the same. Okay. So if you are in this case, if you are on radial 09 0, let's say for example, I know it's not 09 0. So even in case of Doppler VOR, when this signal makes a rotation like this, the radial will be still 09 0. That won't change. Very important. This knowledge is very important for ATPL. Next, a standard rate turn. Very important. We have all exercise. We have all of us have done this particular exercise. Standard rate turns to the right. Standard rate turns to the left. Right. How much time would be required to turn to the left hand side from a heading of 090 from a heading of 090 to a heading of 300? So you are making a left hand turn at a standard rate. Now all standard rate turns are 3 degree per second. That means whenever you are making a standard rate turn, you are turning 3 degree every second. So to make a complete 360-degree turn, the total time taken will be equal to 2 minutes, 120 seconds. Now in this case, we have to turn and how much? 90 plus this 60. So 150 degrees. So we have to make a total 150-degree left turn. So if in case of standard rate turn, if you are turning 3 degree per second, so for 150 degree, you will take or you will require a total time of 50 seconds. 50 seconds. 150 divided by 3 degree. So option Charlie. Simple. The heading indicator is what? So heading indicator is a directional gyro. Earth gyro is your artificial horizon. Okay, or your attitude indicator. Rate gyro is your turn coordinate. So the heading indicator is your directional gyro. Next, aircraft is flying at constant indicated altitude. So it is similar to the question that we did previously. I think question 41, 43 something. The altimeter reading will be what? So like I said before, when you are flying from a cold air mass to a warm air mass, or if you are flying from an air mass which has ISA temperatures to an air mass which are warmer than ISA, the true altitude of your aircraft will be more than indicated altitude, right? So even if the altimeter tells you that you are flying at a constant indicated altitude of 5,000 feet, in reality you may be flying much higher than that, 5,500, 6,000, 7,000, whatever. So the altimeter reading will be correct? No. The altimeter reading will be greater than the real altitude, that is true altitude? No. The altimeter reading will be less than the real altitude, because if you enter a warm air mass warmer than ISA air mass, your true altitude, your real altitude is more than the altitude indicated by your altimeter. That means the altimeter altitude will be less than the real or true altitude. If the needle and the ball of a turn and slip indicator both show right, that means, so I'll take a slide. So here, let's say this is your turn and slip indicator, right? And there is this inclinometer, and then there is this. So currently your aircraft is showing a right hand turn like this, and the ball of this inclinometer is also has also shifted to the right hand side like this. Okay, so the needle shows right hand turn correctly. The job of the ball is to show the quality of the turn. Whether you are slipping or skidding. Now remember whenever the ball moves or falls in the same direction as your turn, in the same direction as your turn direction, that condition is called slipping. That condition is called slipping. That means aircraft, let's say this is the center of your turn. That means aircraft is slipping to the inside of the turn. This is the center. In case of slipping, aircraft is falling inside of the turn. In case of skidding, aircraft gets drifted away outside of the turn. Gets drifted away outside of the turn. Okay. In case of slipping, it falls inside of the turn. In case of skidding, it goes or it gets thrown away outside of the turn. So in case of slipping, next point, we have centripetal force in play. Centripetal. In case of skidding, we have centrifugal, the outward directed force in play. Okay. Next, in case of slip, the angle of bank of your aircraft is excessive. Okay. In case of skidding, the angle of bank of your aircraft is very little. So, in this case, we are getting a slip condition, right? Both ball and the needle is towards the right hand side. So that means you're turning to right hand side. So you are left with only option Bravo after eliminating Alpha and Charlie, and too much bank. So slipping means angle of bank is excessive. So option Bravo. What is density altitude? Very important. Density altitude is your pressure altitude plus 120 into ISA deviation. So I have uploaded two lectures in which I have explained in detail the concept of density altitude. So do watch that. You will find that particular video lecture in two different playlists. One is the name of the first playlist is the knowledge series playlist, and the second playlist in which you may find this particular density altitude chapter is RK Bali General Navigation playlist. So I have uploaded those lectures in these two playlists, and I have also solved all density altitude questions from RK Bali and Keith Williams. So do watch that video lectures. So density altitude is nothing but pressure altitude corrected for non-standard ISA temperature. So that means now your airplane performance, your airplane instruments are all designed or all calibrated according to ISA temperature conditions, ISA conditions. But in real life, we may get ISA temperature conditions, pressure conditions, humidity conditions, but not every time. Okay, not every time is a good luck. So we may be flying in conditions which are warmer than ISA, which are colder than ISA. We may be flying in an air mass whose pressure is higher than the standard pressure that is to be there, or lower than the expected pressure. So in such different varying conditions of flying, the density altitude of your aircraft will be very much different from the actual pressure altitude of your aircraft. To quote an example, let's say if your aircraft is parked at mean sea level airport. Okay, airport is situated at mean sea level. Now the ISA states that at mean sea level the temperature should be or must be positive 15 degrees Celsius, 15. But on that particular day, let's say the temperature at that mean sea level airport is 30 degrees Celsius, double the 15. That means it is warmer than ISA given temperature of 15 degrees Celsius. So in warmer than ISA conditions, your aircraft may be situated at mean sea level, but the performance that your aircraft will produce will be equivalent to an altitude where you are supposed to find that 30 degrees Celsius in ISA temperature conditions. Okay, so you will get 30 degrees Celsius temperature, positive 30 degrees Celsius temperature. So, for example, that means in warmer temperatures, warmer than ISA temperature conditions, what happens is the humidity and the density of air will reduce. Now, when the density of air reduces, the performance produced by your aircraft will be much less, because performance is always proportional or directly dependent on the density of aircraft. If the air is very much dense, the engine performance will be very good. If air is less dense, that means air is very thin, the performance produced by your engine will be impacted, will be hampered. That's why we say density altitude can be different from pressure altitude when three factors are taken into account. First is temperature of the air, the current temperature. The second is pressure, and the third is humidity. So warm temperatures diminish or decrease density of air. Low pressure decrease density of air. Humid air will also decrease density of air. So when these three factors get combined, that will be a very deadly combination as far as your aircraft performance is concerned. So that's why it's always important to include density altitude calculations in your takeoff and landing charts, so as to make sure or ensure that you have sufficient takeoff distance at your airport, takeoff distance available at your airport of departure, and landing distance available at the airport of your destination. So question 49 answer is altitude in the standard atmosphere at which the prevailing density is equal to the density in the standard atmosphere. Yes. And so option A. So whatever density you are getting currently, whatever density is existing at this particular place, at what particular, then you have to ask yourself a question. At what altitude in the ISA temperature conditions or in ISA atmosphere you are expected to find that density? If the density that I'm surrounded by is the density that is normally expected or is normally found at 30,000 feet, that means I may be at mean sea level. But according to density altitude, I am at 30,000 feet. So aircraft may be at mean sea level, but its engines will feel that it is actually operating at 30,000 feet. Okay, so it's no use standing at mean sea level or parked or operating or moving at mean sea level if your aircraft engines are going to produce performance that are to be produced at 30,000 feet. So you lose that advantage of flying at mean sea level. Question number 15. What is Mach number? Mach number is the ratio of pitot pressure to dynamic pressure, static pressure to dynamic pressure to static pressure. So the correct answer here is the ratio of, so Mach meter is nothing but a combination of your altimeter and your airspeed indicator, right? So the correct answer here is the ratio of dynamic pressure to static pressure. Yeah. So with this, we come to the end of this lecture. So I hope you have understood all the 10 questions that I answered explained, elaborated in this particular video lecture. If you have any doubt, any comments, any feedback, any query, let me know in the comment box of this video lecture. I will definitely resolve them. Keep practicing these questions again and again. I will upload many more questions. Do practice them also. Please share this video with your friends who are also preparing for the exam, be it CPL, ATPL or airline exam. Subscribe to this channel if you haven't yet and share this video with your friends like I said. Hit the like button if you have liked this video lecture.